Hi everyone. Today we're going to learn about aromatic hydrocarbons. I really like this topic. I think most of you will like this one too. So first of all, aromatics. So these are all derivatives of benzene. Okay, first I'm noticing my font is like messed up here. This is weird. Anyways, these are all derivatives of benzene. So benzene is C6H6. So what that means is you've got 6 carbons and 6 hydrogens, and they're in a ring here. So they look like this, okay? Now, aromatics, the word implies that they smell, and they do. Aromatics are what we use in all of our perfumes, artificial food flavorings. These all come from aromatics. They're all derived from benzene. So benzene contains 3 double bonds and is an acidic hydrocarbon. A cyclic, not acidic, is a cyclic hydrocarbon. So it's in a circle like this. So what happens is the double bonds seem to change position or resonate, and these are called resonance hybrids. And I'll talk more about that on the next slide here. But data indicates that all the bonds are equal in strength. So basically, we draw it here as showing the 3 double bonds, but in reality, none of them are double, none of them are single. And I'll just show it to you in the next slide here. So again, data collected shows that all the bonds are equal in strength. So we've got 6 carbons in a ring. So I'm just going to draw them here. And so we've got the double bond is alternating, right? And then we've got a hydrogen on each of those. Let's put a hydrogen on each. So what this means is that, oh, my phone's dinging. What this means is that we've got what's called resonance hybrids. So I'm going to draw 6 carbons again, but I'm going to move the double bond. So now the double bond has just moved over 1 position. Again, we've got our hydrogens. And so these are what's called resonance hybrids. And so what this means is that the true structure of benzene exists here. It's right in the middle of between these 2 structures. So instead of the double, it doesn't necessarily alternate single, double, but we kind of have like an average between them. But we tend to write it like these. But just know that in reality, benzene is kind of somewhere in between these 2 things, and they're called resonance hybrids. Okay, so the representative symbol for benzene is going to be a hexagon. Don't draw an octagon. Sometimes people start drawing octagons. It's only 6, so an octagon with a circle in it. And what that means is every single point is a carbon with a hydrogen attached. So we don't draw the hydrogens, but just know that those are all there. Now, sometimes we can, instead of a hydrogen, we can have an alkyl group there too. So sometimes we can substitute things off of those different carbons there. So naming aromatics. Man, my font is totally messed up and it's mixing me up here. I don't know what happened. Anyways, naming aromatics. So substitution, we're going to replace one of the hydrogen atoms of the benzene ring with a hydrocarbon chain. So with a radical group. So these are our normal radical groups that we have. So we've got our methyl group, our ethyl group. Propyl is here, right? That's what I mean by an alkyl group. That's a radical group. So naming them. So when the benzene ring is attached to an end carbon, so this would be, I'm going to draw the first one here. So I've got my hexagon, and then let's put a methyl group there. So this is called 1-methylbenzene. So the benzene acts as the parent, that's that one there, and then we've got, this is your radical here. Now, if I were to draw 1-ethylbenzene, I'm going to draw the same benzene, and then instead of drawing a methyl group, I'm just going to draw an ethyl group. I'm just going to abbreviate it there, C2H5. Now, does it matter which carbon I put these on? No. Again, remember these exist in 3D and all bond strengths are equal, so it can be on any one of those carbons. And then, so this one's here. And then the third one, 1-propylbenzene, again, you've got, oh, I can't go that low there. Again, oops, oh boy, let's erase that. Okay, again, you've got your benzene, and then your propyl group, let's put it over here, C3H7. So that's going to be 1-propylbenzene. So in your notes there, it didn't have the 1-, so just add that in, okay? Good. Now, if the alkyl group is attached to the benzene ring by other than the end carbon, now you have to consider the benzene as the radical and the alkene as the parent chain. So when the benzene becomes the radical or the alkyl group, we call it a phenyl. You would think we would call it a benzyl, but that just makes far too much sense. It's called a phenyl group. Sometimes you will see benzyl, but the SI, so System International way of naming it is using phenyl. So you've got some examples there in your notes, so I'm just going to copy the first one down here. So you've got your benzene ring, and then it's attached to a middle carbon here. So we've got, so we've got a middle carbon here. So at this point, this becomes the radical. So that's our phenyl. The other one is our parent chain. Now, all other aspects of naming are going to be similar here to what we're used to seeing. So you're going to start counting. You're going to start from the end closest to the radical. In this case, it doesn't matter, right? So the name of this, 2-phenyl dash, and oh no, sorry, I don't need a dash there. There we go. And then I look at the parent chain, which is this one. So 3 carbons in a row is going to be propane. So 2-phenyl propane is going to be the name of this one. Now the next one is, I've got 5 carbons in a row, so a 5-carbon chain. And then you've got the phenyl group in the middle there again. So you're going to start your numbering. It doesn't matter again for this one because they both end up with 3 for the phenyl group. And so the name of this molecule, that's your radical, is going to be 3-phenyl. And then again, I've got 5 carbons in a row. They're alkanes, pentane. So 3-phenylpentane. And then one more there. So the last example on your page is showing benzene. Oof. So I've got benzene, and then you've got 1 CH3 coming off of it. So technically, this one could be named 2 ways. You could call this 1-methylbenzene, or you could call it 1-phenyl methane. Either one of those would be acceptable answers for that one because it's on the N carbon, okay? So that's the only one where that's true though. Okay, so we're going to take a look at di-substituted. So what happens when you've got 2 things substituted on it? So 2 hydrogen atoms have been replaced on your benzene ring with alkyl groups. So we're going to be, again, you're always looking for lowest numbering combinations. So you always want to pick the lowest numbering combinations, and then the alkyl group that gets the lowest number is the one that you would name first. So that's going to be alphabetical. So the one alphabetically that comes first, it gets the lower numbering combination. Now there's 2 ways of naming these. So we have the alternative naming, and so you need to know both ways. This one's using the prefixes ortho, meta, and para, and I'll explain how this works when we go through examples. So Ortho, this is when we have groups on adjacent carbons. So adjacent just means they're right next to each other. So this would be positions 1 and 2. Meta means that they have an empty carbon between them. So this is 1 and 3 position. And then para, 2 empty carbons between them. So this would be the positions 1 and 4. So write that down, and that will make much more sense when we take a look at a molecule here. So the first one in your notes. Okay, so we've got our benzene, and we've got a CH3 group going to the top there, and then we have one down here, which is C2H5. Okay, so when we name these, first thing I like to do is just write alphabetically what they are. So that's a methyl group. That's an ethyl group. So right away I can say to myself, okay, I'm going to start my numbering from the ethyl group because that comes first alphabetically. Now, I have two choices. This is my number 1 spot. If I go counterclockwise, which is this way, it would be 1, 2, 3, 4, 5. So the positions would be 1 and 5. I don't want that though. I want the lowest numbering combination. So instead of going counterclockwise, I'm going to go clockwise to 1, 2, 3. So my positions are 1 and 3 for these. So there's 2 different ways I can name this. So I can name it 1 dash ethyl dash 3 dash methyl benzene. And benzene is going to be the parent chain here. So 1 ethyl 3 methyl benzene. Or I can name it the much more fun way, because it's fun to say. You can say meta, so you just put the letter M. So meta, and then you would write, and you would say it very quickly, ethylmethylbenzene. So M, ethylmethylbenzene. So it's just a more fun way to say it. Either way is completely acceptable. You can use either, I don't care, but you do need to be able to recognize both ways of naming. Okay, let's look at the next one. So this one, the positions are going to be in 1 and 4. So I've got a CH3 here, and I've got a C2H5 here. So again, right away I'm going to say this is an ethyl group, this is a methyl group, so I'm going to start numbering from the ethyl group. So 1, now in this case it doesn't actually matter which way you go. You're going to get positions 1 and 4 either way. So it's going to be 1 dash ethyl dash 4 dash methyl benzene. Or again, the more fun way, para dash ethylmethylbenzene. And either way is acceptable, so you can pick which one you like. Third example there, we've got, so again, our benzene. And we've got positions 1 and 2, so right next door to each other here. So I've got a CH3 and a C2H5, and again, we're gonna find the ethyl getting the number 1 spot due to alphabetization. And so the name of this then, 1 ethyl 2 methyl benzene. Or we can call it ortho ethylmethylbenzene. Okay, ortho ethylmethylbenzene, that's the other way. Okay, so I'm trying to write this quickly, which I know is kind of sloppy, but you have these typed out for you nice in the notes anyways, so hopefully you're okay. Okay, next thing we're going to look at is polysubstituted. So again, poly, you know this from math, is many. Okay, so it's going to be more than 2. So we've done single substitution. The di substitution has its own set of namings. There are some alternative namings. But now the polysubstituted doesn't have any unique way of naming it. You just want to look at lowest numbering combination as well as alphabetization. So the first example, I'm just going to draw it here. So I've got my benzene, and then substituted on it, I've got a methyl group. I've got an ethyl group, and I've got a propyl group here. Oops, that's a 7. Hold on. Okay, be a little neater for you guys. That's a 7. Okay, now looking at this again, I'm going to put my letters on here so I don't mess up the alphabetization. So I've got E, M, and P, so I'm going to start with E. This is going to be my number 1 spot. Now, both ways that I go, I'm going to end up with radical groups in positions 1, 3, and 5. So you could think, well, they're both the same. No, they're not. So there is a correct choice for this. So how it works, if you go clockwise, it's 1, 3, and 5, but you would have methyl before propyl. If you go counterclockwise, which is this direction, you would have propyl. So again, it would be 1, 3, 5, but you'd have propyl before meta. And alphabetically, that is not acceptable. So we are not going to go that direction. You are going to make sure that you go, so I think I said it backwards, didn't I? I think I'm like saying counterclockwise and clockwise backwards, and now I'm paranoid that I did it on the other examples. My apologies. Wow, it's been a long year. So we're going to go we are going to go counterclockwise. So 1, 2, 3, 4, 5. So this is our counterclockwise here. And now the name of this is going to be 1-ethyl dash 3 dash methyl dash 5 dash propyl benzene. So kind of a beast of a name here. And some of these they feel really complex. And remember, if you had things like, if you had 2 methyl groups, you'd say dimethyl. So for example, let me just show you that real quick. So say you had this, say you had CH3, CH3, CH3. The name of that, those are all methyl groups, right? So the name of this molecule would just be 1, 2, 3 dash trimethyl benzene. Okay, so those other rules of naming apply here as well. So you have to factor all that stuff in there. Okay, so this is typical of a question that you'll get in organic chemistry, where I give you a structure, I give you a name, and tell me what's wrong with the name and what's the real accurate name. Now you're going to see molecules drawn like this at times. So instead of doing the circle in the middle, they'll draw the double bonds. Now remember, every time there's a point, that's a carbon, which means this here is a carbon. So I'm just going to draw that out for you. So the name given is 4-ethyl 1,2-dimethyl benzene. So again, this is a methyl group, this is a methyl group, this is an ethyl group here. Now, right away, hopefully you can pick up what's wrong with the name. They've got number 4 for the ethyl group. But we know, because you guys are all nice and smart, you know that the ethyl gets named first. So this is going to be 1, 2, 3, 4. So the real name of this molecule is going to be 1-ethyl dash 2, 4 dash dimethyl benzene. So that is the real name there. 1-ethyl, 3, 4. No, it's, you know what? Sorry, my diagram, shoot. This diagram is a little different from what you have in your notes. Let's just change it. In your notes, it's this way. So CH3 there, so it's 1, 2, 3, 4. So it's actually gonna be 3, 4. So 1-ethyl 3, 4-dimethyl benzene. My apologies. Okay, so that's it for that. So worksheet number 3 is assigned now. I'll post the answer key. Again, please make sure you're asking if you're struggling with this at all. We'll try to have a meet so we can go over some stuff too. Okay, that's it for today. Thanks, guys.